Good morning, girls. Today we have start with degrees of freedom. So, what is meant by degrees of freedom? The number of independent waves in which a mechanical system can move without any constraint which may be imposed in that particular system is called number of degrees of freedom of that system. So, here we considered a system having 3n coordinates with n number of freely moving particles. So the system having n number of freely moving particles, the total number of particles can be represented by the letter capital N. So the system having the 3n degrees of freedom. So it can be commonly written as Ri equal to I or xi plus j or yi plus k or zi, where I having a values of 1 to 3 up to n. So, for example, we have considered n single particle moving in a space. It has 3 degrees of freedom. Why it has 3 degrees of freedom? Because it will be moving in all the directions. It will be freely moving in all the directions. So, it has 3 degrees of freedom. But if the constraint to be moved in a certain space, it has only 1 degrees of freedom. Why it has 1 degrees of freedom? Because the condition imposed on that particle, it will be moving in only one direction, so it has only 1 degrees of freedom. Okay, so similarly we considered a rigid body. So a rigid body having a rotation about its own fixed axis, so it has only 1 degrees of freedom. So it why it has only 1 degrees of freedom? Because the rotational angle will be rotating in a one particular direction, so it has only 1 degrees of freedom. So the number of degrees of freedom can be commonly denoted by the letter f can be written as 3n minus k, where 3n is a number of coordinate system, k is a constraint imposed on that system. Okay, so for a particle, the conditions imposing in a system is a way of simplifying the problem mathematically, in that the number of equations of motion are reduced to the same number of degrees of freedom. So here we consider a system of n number of particles having independent constraints will be imposing on that system. So the conditions we are applying to that system will be independent. So for we have already seen that or I equal to I or xi plus j or yi plus k or zi. Okay, so here we considered n particle having an individual particle. So for a first system, we have written the equation as first system of, so we have considered a first system as g1. So g1 having a coordinates of x1 y1 up to zn with respect to time will be equal to constant. The equation can be written as g1 of x1 y1 up to z1 t will be equal to constant. So for a second term, we have written the equation similarly as first equation. So g2 of x1 y1 up to zn t will be equal to constant. So likewise, the third system, fourth system, fifth system up to nth system, the equations will be equal to be constant. So the number of degrees of freedom can be written as f equal to 3n minus k. Okay, thank you.